So this is Geometry Chapter 5, Section 4, Medians and Altitudes. Okay, so we have a triangle. This is a median, actually. Let's talk about median and triangle. So median of a triangle is a segment whose endpoints are the vertex and the midpoint of the opposite sides. So it's a segment. It's inside the triangle. So a segment in a triangle whose endpoints are the vertex and midpoint of the opposite side. Okay, so what does that mean? We have our triangle. Triangle has three vertexes, right? Or vertices. So this is a vertex. This is a vertex. This is a vertex. So it's going to be a segment within the triangle whose endpoint, one of the endpoints, is going to be the vertex. And as I draw it down, it's going to be the midpoint of the opposite side. So what's opposite of this vertex? This guy here. So those two guys are midpoints, and I have one guy here. I draw it this way, and then these two guys are the midpoints here. So vertex, opposite side. And then this guy here, and over here, you have 1, 2, 3, 1, 2, 3 again. Vertex, midpoint of the opposite side. So these are all medians, a segment within a triangle whose endpoints are the vertex and the midpoint of the opposite side of that vertex. With that, we have something called the concurrency of medians. What is concurrency? And concurrency was something that was taught of in the previous section, but we skipped it. So what concurrency means, if I spelled that right, concurrency means an intersection of three or more lines, an intersection of three or more lines. So here would be my point of concurrency, because these are where my three lines intersect. All right. Concurrency of medians or triangle. So let's label these things. We have F, we have D, we have E. At the midpoint, we have G, we have H, we have J, and then in the center here we have C. And they all meet at this point of concurrency right there, right? The concurrency of the medians of triangles theorem. And it says this: the medians of a triangle are concurrent at a point that's 2/3 the distance from each vertex to the midpoint of the opposite side. 2/3 the distance from each vertex to the midpoint of the opposite side. The medians of the triangles are concurrent at a point that is 2/3 the distance of the vertex to the opposite side. Meaning, this guy right here is 2/3 from this guy to this guy. This guy right here is 2/3 from this guy to this guy. This guy right here is 2/3 from this guy to this guy. Meaning, if I look at the whole entire median of DJ, hey Mr. DJ, actually, the distance here, DC. So from the vertex to the point of concurrency, DC, it is equal to 2/3 the distance of the whole entire thing, DJ. If I was looking at CF, or FC, is going to be equal to 2/3 the distance FC of the whole entire median, which is FH. If I was to look at CE, it is equal to 2/3 the entire distance of the whole entire median GE. Okay. All right, so that is theorem 5.8, concurrency of medians. Theorem. Okay. The distance from the vertex to the point of concurrency is 2/3 the distance of the vertex to the midpoint of the opposite side. Okay. The point of concurrency of medians is also called a centroid. So centroid is, I'm going to put POC for point of concurrency. Point of concurrency of the medians is called a centroid. And it's also called the center of gravity. And the reason why it's called the center of gravity is because if we were to cut out a triangle and we were to have the meet all at the centroid, you can hold your finger at the centroid and it would be perfectly balanced. Okay. All right, so with that information in mind, we have this triangle here, and it tells me that we have ZA, and ZA is equal to 9. I know that that's from the vertex to the centroid. So ZA, thinking about the equation, is equal to 2/3 of the vertex to the median midpoint of the opposite side. So that would be CZ or ZC. And they want us to find the length of ZC. Well, in order to find the length of CZ, we're going to substitute 9 for ZA, time equals 2/3 ZC. In order to get rid of the fraction, we always multiply by its inverse, or its reciprocal. And what I do on one side, I do to the other. These guys go away. 3 times 9 is 27. 2 times 1 is 2. So the whole entire median would be 27 over 2. Okay? All right. They also ask you to find the ratio of Z to A to C. If we think about ZA being 2/3 of ZC, then I have this remaining thing left here, right? CA. And I can get that by subtracting 3/3 minus 2/3, and that's actually going to give me 1/3 of ZC. Right, so CA is 1/3 of ZC, which makes sense, because 2/3 plus 1/3 of a segment gives me the whole thing. So if I wanted to get the ratio of ZA to CA, or AC, the ratio is just a fraction, right? So the ratio is going to be 2 to 3 over 1 to 3. Right. and I can get rid of that by multiplying, right? Division is the same thing as multiplying by its reciprocal. So this is going to be the same thing as multiplying by 3 over 1, 3 over 1. And our ratio would be 2 over 1, or 2 to 1. So that means that when we have our median and they meet at the centroid, that the distance of the longer side is always going to be 2 times the distance of the smaller side. For example, if ZA, right, ZA is equal to 9, then I would just divide that 9 divided by 2, and that would give me CA, which would be 4.5. And that would make sense because we said it was 27 over 2, and 27 over 2 is equal to 13.5, which is 4.5 plus 9. So that makes sense. Okay. Altitude. Altitude is a perpendicular segment from the vertex to the line containing the opposite side. So altitude. Perpendicular segment from the vertex to the opposite side. Perpendicular segment from the vertex to the opposite side. So what does that mean? I have a triangle. We now don't think of this triangle as the opposite segment. We're thinking this as a whole line this way. A whole line this way. So the altitude would be from the vertex to the line containing the opposite side. Here's my line, and the opposite side of the triangle is within this line, and it's going to be perpendicular. Same thing over here. It would be a line containing the opposite side, and altitude would come from here to here, and it would be perpendicular. And then same thing over here. Not just the opposite side, but the line containing the opposite side. And this vertex would be from here to here. These guys are not matching up, but that's fine. From here to here. Okay? That is the altitude. There's 3 ways to write altitudes. We just did one way with the acute triangle, where the altitude would just come straight down and be perpendicular. Another way to do it is if we have a right triangle, the altitude is the same thing as one of the sides. So this would be the altitude. We also call it the height when we do area of triangles. Altitude, height, same thing. When we have an obtuse triangle, remember, it's the line containing the opposite side. So we can have altitudes that are outside of the triangle, and this would be my altitude right here, because the line containing the opposite side extends out, and we can get the altitude that way. So these are all altitudes. Okay. Okay. So they want you to know if it's a median, altitude, or neither. If I look at AD, A comes from the vertex and it goes and it's the midpoint of the opposite side, right? So it's cutting this in half. So AD would be the median from the vertex to the midpoint of the opposite side. If I look at EG, EG is parallel to the opposite to the opposite side, but they don't cut anything in half. I mean, it cuts this guy in half. It's something else, but it's not the median. It's the mid segment, and the mid segment doesn't come from the vertex. The mid segment meets at the midpoints of both sides of the triangle. So EG is neither. It's not altitude or a median. It is neither. Then we have CF. CF comes from the vertex and it forms a perpendicular intersection with the line containing the opposite side. This guy is altitude. Okay. AG and median. EG is neither. CF is the altitude. Okay. And we're not doing anything further. We're not talking about concurrency of altitudes and orthocenters and things like that, so don't worry about it. And that is this section. Hope you have a great rest of your day.